Let's take a look at some beginner problems on exponential functions. Select all the following functions that represent an exponential function. We have f of x equals x to the e power. We have g of x equals 3 to the x power. H of x equals x cubed. Q of x equals 4 over 5 raised to the x power. And r of x equals 1 over x. So we'll begin with f of x equals x to the e. That's not an exponential function, since our variable, which is x, does not appear in the exponent. The number e appears in the exponent. So e is 2.71828, and it continues on forever and ever like pi. So we have a number up in the exponent, meaning it's not an exponential function. Whereas if we look at g of x, we have 3 to the x. Notice the variable appears in the exponent, and that's the only place the variable appears. So the function f of x equals, or g of x equals 3 to the x is an exponential function, since it's of the form y equals a times b to the x, where a is not equal to 0. And b is greater than 0 as well. If we look at our next function, h of x, we have equal to x cubed. Notice there's a 3 up in the exponent, meaning it's not the variable. The variable appears as the base, so this is not an exponential function. On our next one for q of x, it's a little bit trickier. We have 4 over 5 to the x. Well, another way to write this is 4 times 1 over 5 to the x, and that's the same as 4 times 1/5 to the x. So notice, even though it didn't seem like it initially, we do have our variable in the exponent. And you can see that actually just appearing in the denominator. So what in fact happens is we do have an exponential function where our a value actually equals 4 and our b value is equal to 1/5. Last but not least, we have r of x equals 1 over x, so you might think it's of the same notation, but notice we have this just x to the negative 1, and so since it's x to the negative 1's in the exponent instead of the variable, so hence it's not an exponential function. Moving forward, let's consider the functions f of x equals 1/3 raised to the x power and g of x equals 8 to the x. Write the values of f of negative 2, f of 1, g of 0, g of negative 2, and g composed with f of 1 in increasing order. So we'll begin with f of negative 2. If you have f of negative 2, notice negative 2 has replaced the x. So essentially this is just 1/3 to the negative 2 power. And what does that mean? Well, with the negative 2, you can flip the base. So instead of 1/3, we'd have 3. So this is 3 over 1 squared. And 3 over 1 is just 3, so this is 3 squared, which is 9. In a similar manner, f of 1, we get equals 1/3 raised to the 1. So you raise the numerator and the denominator raised to the first power, or you can realize that anything raised to the first power will actually be that original number, which is 1/3. On to g of 0. G of 0 will have 8 to the 0 because we're replacing the x in that g function now. So 8 to the 0, anything raised to the 0 power, that's a positive number I should say, raised to the 0 power, will always equal 1. Okay, g of negative 2, let's take a look at that. So this is 8 raised to the negative 2 power. What does that do? Well, that changes the 8 into 1 over 8, and then we're supposed to square that quantity. So now, moving forward from here, we're going to square the 1 and square the 8, and that gives us 1 over 64. Last but certainly not least, g of f of 1. And we wrote it in a slightly different way, but this all means the same. So first we need to calculate f of 1. So the way to do that is we find the f function. We have 1/3 raised to the x. We're going to plug in 1 into that for the x. So we have 1/3 raised to the first power. So that this will be g of 1/3 raised to the first power, which is the same thing as g of 1/3. Okay, so now we want to plug in 1/3 in for the g function. Okay, well if we plug that in, we get 8 to the 1/3, which is the same thing as the cube root of 8. And the cube root of 8 happens to be 2, because 2 times 2 times 2 equals 8. Okay, so now let's write these in increasing order. If you look, the smallest value here is actually 1 over 64. And then we have 1/3, 1, 2, and 9. And to write those corresponding to the function, 1 over 64 is g of negative 2. 1/3 happens to be f of 1. 1 equals g of 0, 2 actually corresponds to g composed with f of 1, and 9 corresponds to f of negative 2. So writing that out, you have g of negative 2, f of 1, g of 0, g composed with f of 1, and f of negative 2. All right, let's take a look at our next problem. Radium-226 is a radioactive substance with an annual decay rate of 0.04%. A series of coal mines in Poland contain an abundance of the aforementioned isotope of radium. If these coal mines contained 400,000 kilograms of radium-226 in 1937, then how much radium-226 would be left in those coal mines in 2017? Round your answer to the nearest kilogram. So taking a look at this, we need to use a formula that corresponds to annual decay rates of radioactive substances. And the way to do that is to look at the formula which we call PERT, and that's F of t equals P times E raised to the RT power, where F of t represents the amount of kilograms left of our original substance, which is radium-226 in this case, after t years have passed. P is the initial amount of radium-226, and R is the rate of decay written as a decimal. Okay, so we need to find some values here within this word problem. If you notice, one of the easy ones that we can start with is the 400,000 kilograms of radium-226. And so we have P equals 400,000 because that's the initial amount of radium-226. If you look, you have an annual decay rate of 0.04%. And so that means that our R value, written as a decimal, is going to be negative 0.0004. Notice, why is it negative? Because we're decaying rather than increasing our amount. Okay, what is our T value? Well, our T value, if you notice, it says from 1937 to 2017. So that should be, if you subtract those two, you should get 80 years. So now we're ready to plug into our equation, and we get 400,000 e to the negative 0.0004 times 80, where the 80 is also up in the exponent. And this leads us into, in order to calculate, we need a calculator to get our answer. And luckily we have our calculator right here. And we just plug in, we get 400,000 times, now E is right above the natural log button. So in order to do that, we'll hit second, and then the natural log brings that E up in our calculator right here. And we just hit negative. Notice we're hitting the negative symbol rather than the minus symbol. 0.0004 times 80. Then we want to close off that parentheses. Make sure that 80 is in that parentheses for the exponent, even though it doesn't appear down below. We want it in our calculator to appear up in that exponent. So we hit enter, and what do we get? We get 387,000, and when we round to the nearest kilogram, it'd be 403. So just plugging that in into our final answer, we get 387,403 kilograms. Moving forward to problem 4, we have Gordon Gekko wants to invest $50,000 into a 10-year CD compounded semi-annually with an annual interest rate of 3%. If Gordon leaves the money in the CD for all 10 years, how much money will he have when the CD matures? And we aren't going to account for taxes here or anything like that. But round your answer to the nearest cent. That's what we'll want to do. Okay, so we need to know the compound interest formula because we're compounding here, and it says compounded semi-annually. So taking a look at that, we have the compound interest formula is given by A of t equals P times 1 plus R over N raised to the NT power. Our P is our initial amount invested. A of t is the amount after t years have passed. And we have R as our annual interest rate. And N is our number of times compounded per year. So keeping all that in mind, what is our P value? Well, if you look, we have $50,000. So P is 50,000. What is our R value? Well, we're compounding with an annual interest rate of 3%, so writing that as a decimal, and we're increasing this time, so it's 0.03. And our N, we're compounding semi-annually, so that would be 2 times a year, so N equals 2. And our T value, if you notice, is a 10-year CD, and we're keeping our investment in all 10 years, so T equals 10. So now let's try and find our amount of money. If you look, we have A of t, because that's the final amount that we're looking for, and this should equal 50,000 times the quantity, 1 plus 0.03 divided by 2 raised to the 2 times 10 power. So we're ready to go with our calculator, and we first begin by punching in 50,000. So 50,000 times our quantity, 1 plus 0.03, divided by 2. And notice the order of operations will stay in play, so we don't have to worry about putting parentheses around the 0.03 divided by 2. But here's where we do have to be careful with parentheses. We hit the caret, and even though you don't see parentheses in the problem, in order to keep this up in the exponent, this 2 times 10, I understand you can put it as 20, but just for future reference, we have 2 times 10. We need to put that in parentheses so all of that appears up in the exponent. Otherwise, it'll take the 10 as multiplication. So keep that in mind when we're doing this. And when we hit enter, we want to round to the nearest cent. So it looks like $67,342.75. And just putting that in our final answer bin here. Now, with our final problem, let's solve for x in the following equation. 4 raised to the x power equals 1 over 64. So how do we do this? Well, the idea is to try and get 1 over 64 written as 4 to some power, if possible. In this case, it is possible, because first off, we have 1 over 64. That's the same thing as 1 over 4 cubed, right? Because 64 can be written as 1 over 4 cubed. So 1 over 64 equals 1 over 4 cubed. Now, what about the 1 over 4 cubed? What's another way to write that? Well, notice, in this case, we have 1 cubed is still 1, so this is 1/4 cubed. Okay, moving forward, where do we go from here? Well, you can flip this because we want to write it as 4 to some power. So rather than 1/4 cubed, we can write it as 4 over 1 raised to the negative 3. And 4 over 1 is the same thing as 4, so this is essentially just 4 raised to the negative 3 power. Now we're ready to solve. Because you have 4 to the x equals 1 over 64, and 1 over 64 is just 4 to the negative 3, so this is the same thing as writing 4 to the x equals 4 to the negative 3. Now, exponential functions are 1 to 1. That's actually quite important because that gives us an answer. So it's the same as both sides. You just set the exponent on the left-hand side equal to the exponent on the right-hand side, and we get just simply x equals negative 3.